again. So it's been a small gap. Last class, I could not take. So now we will finish. We are going to go a little faster, but still, we have covered some basics. நம்ம last classல வந்து second chapter ஓட basics எல்லாம் பார்த்தோம். Scalars, vectors அதெல்லாமே பார்த்துட்டோம். So we are going to look at questions based on that. So let me start sharing my screen and சொல்லுங்க screen வந்து if it's visible to you. Yeah, I'm just about to share the blackboard. I hope you guys are able to see it. So எல்லாருக்கும் visible இருக்குன்னு நம்புறேன்.
Yes, sir.
Yes, okay. Yeah, so we'll start off with the questions directly without any further delay. Last classல வந்து நான் உங்களுக்கு எல்லா ஃபார்முலாஸும் கான்செப்ட்ஸும் நம்ம பார்த்துருந்தோம், and that was also shared on the WhatsApp groups. So based on that concepts, so நம்ம questions பார்த்துடலாம். So we'll see problems based on that. So I'll just write the questions and give you the options. You can start working them. Just put today's date, auspicious day today. Okay, so here comes the practice questions. Based on the NCERT chapter 3 of grade 11. So here comes question number 1. Oh. We'll start with easier ones. So here comes the first question. The angle between vectors. So I'm specifying the vectors here. Renda vector tharan. So that is vector A, which is 3i plus 4j plus 5k. Okay, and vector B, which is equal to 3i plus 4j minus 5k. So I've given you two vectors. The question is, you will have to find out what is the angle between them. Options kudukren. I'm giving you the options also. First option is 0 degrees. Second option is 45 degrees. Third one is 90. And fourth one is 180 degrees. You can start trying. We have two vectors based on three-dimensional Cartesian coordinate system. It is given. So you can tell me what is the angle between these two vectors. You can try. I'll just give you a minute or two to think. You can try it and let me know.
Sir, 0 degrees, sir.
0 degrees. Okay. So, என்ன பண்ணீங்க? How do you arrive at 0 degrees?
Sir, cos theta equal to a vector dot b vector by mod a vector mod b vector, sir.
Correct. Perfect.
Sir, a vector dot b vector 3 3s are 9 plus 4 4s are 16 minus 5 5s are 25, sir.
Okay. So நீங்க இந்த ஃபார்முலா யூஸ் பண்ணீங்களா? That is vector a dot vector b is equal to mod a into mod b into cos theta. Yes.
Yes, sir.
இதுதான் யூஸ் பண்ணீங்களா?
Yes, sir.
Okay. So இது யூஸ் பண்ணீங்க. So mod values சொல்லுங்க. We'll verify it. So what is mod a value and mod b value? If you have calculated.
Actually 90 degrees, sir. Sir? Sir? Sir, can you hear me, sir? Sir? Hello, sir. Can you hear me, sir?
Yes, I'm back.
90 degrees, sir.
Okay, mod A value calculate panning. I'm just interested to know what is modulus of A, which is
Sir.
3 square plus 4 square. அது பண்ணீங்களா?
சார் இல்ல சார், அது அந்த mod A by mod B வந்து இங்கிட்டு
ஏன்னா எனக்கு mod A வந்து 5 root 2 வருது. Same is for mod B also. Isn't it? And what is vector A dot vector B? Dot product of vectors பாத்தீங்கன்னா நீங்க அந்த ரிலேஷன் யூஸ் பண்ணலாம். I cap dot I cap relation.
Manish, 1 minute. Raja Tankaya, என்ன what is your question? நீங்க அங்க ஹேண்ட் காமிச்சா இங்க அவருக்கு தெரியாது. நீங்க மைக் ஆன் பண்ணி தான் பேசணும். சரிங்களா? whoever wants a doubt you come with the mic. hands பார்த்தா அவர் பார்க்க முடியாது because he is presenting, no, so அதனால பார்க்க முடியாது. Okay, right, carry on.
Yeah. Okay. Yeah, so vector A dot vector B. So நீங்க அந்த ரிலேஷனை you can directly start using it, wherein you have 3i plus 4j plus 5k. So நீங்க இதை வந்து டாட் பண்ணுங்க. So you need to find out the dot of this. இங்க வந்து we have minus. So minus 5k. So you need to find out the dot product. Yeah. So try to multiply. So you know that I dot I, J dot J, அப்புறம் K dot K எல்லாமே 1 ன்னு உங்களுக்கு தெரியும். Isn't it? So we make use of that. So which is இங்க 3 3s are 9 வரும் உங்களுக்கு. அதுக்கப்புறம் 4 4s are 16 வரும். 5 5s are 25 you get. Isn't it? Which upon adding you're going to get 50. Isn't it?
50, sir.
Yeah, 50 வரும்.
minus 25 இல்லையா சார்?
Okay. Minus?
5 sir, minus 20.
Yes. Minus sign. I missed on that. Thank you for correcting me. Yes, it's minus. Okay. So அப்போ இங்க என்ன வருது உங்களுக்கு? So I think it becomes 0, right? 9 plus 16 எப்படி இருந்தாலும் உங்களுக்கு 25 தான். So இங்க 0 ஆயிடுது. Correct? Yes. So 0 is equal to cos theta you get. So theta is cos inverse of 0. So what is theta?
90 degrees.
Exactly. It has pi by 2 radians or it is 90 degrees. சரிங்களா? So the answer is 90. Okay? Correct. So this is how we approach this question. I hope I'm clear. இந்த மாதிரி தான் நம்ம வந்து இந்த கொஸ்டினை அப்ரோச் பண்ணுவோம். ஸோ ஜென்ரல் இந்த ஃபார்முலா நம்ம யூஸ் பண்ணிட்டு போயிட்டே இருக்கலாம். ஸோ யூ நீட் டு யூஸ் A dot B is equal to mod A times mod B into cos theta. Simple as that. So this is how we approach this question. Okay, I hope எல்லாருக்குமே கிளியரா இருக்குன்னு நினைக்கிறேன். So if anybody wants to ask something, please don't hesitate. Directly நீங்க you can unmute and you can ask. Okay, you can interrupt me anytime. We are here to help you. All right. So moving on to the next question. I hope all the doubts are clear. I mean, this question is clear of how it needs to be solved. Okay, a simple one. So we'll eventually move on to complex questions. Moving on to question number 2, we'll see another question. This is a different model altogether. Yeah. So here comes a question. 2 balls are projected. 2 balls are projected making angles 30 and 45 degrees with the horizontal. Okay, with the horizontal. If both have same velocity, at highest point, of projectile, the ratio of their horizontal ranges are So this is a question. I'll give you the options. 1 is to 3. Option A. Option B is 1 is to root 3. Option C, 3 is to 1. And option D, root 3 is to root 2. So in the question, they have given that two balls are projected making angles of 30 and 45. So there are two balls being projected, they're making an angles of 30 degrees, and the other is projected with an angle of 45 with the horizontal. Suppose both have the same velocity at maximum height, then you will have to find what is the ratio of their horizontal ranges. That is a question. Okay. Yes. So how would you approach this question? So you have to use the relation for the horizontal range of the projectile. It's projected from the ground level. So what is the formula for horizontal range?
U square sine 2 theta by g.
Correct. So u square sine 2 theta by g. And the relation தான் you will have to use. ரெண்டுத்துக்குமே பாத்தீங்கன்னா they have the same velocity at highest point கொடுத்துட்டாங்க. Simple. So horizontal range is r is equal to, as you rightly said, u square sine 2 theta by g. Okay, in the formula now. So either use pannona, you will be getting the ratio, but correctly you will have to use it given the condition. Anybody's got the answer? Can you just make a guess in case? Otherwise, I'll show you how it needs to be done. Slightly tricky, but it is. If you think, you will get it.
Option B, sir.
Yes, option. Second one.
Yes, sir.
Cherry. Second I last one pakla. No worries. Fine. Okay. One of you is saying option B. We'll see it. So here, we are talking about two balls being projected. So we have two different angles being involved. Okay. So let us say R1 for the first case, for the first ball. So what is R1 according to the given situation? It is u square sine, we say 2 theta, right? U square sine 2 theta. That means 2 times 30 degrees. U square sine 2 theta upon g. Same way, R2. Second ball projection angle pathingana is 45. So u square sine 2 times 45 degrees upon g. Okay, in the mari ungalku relation varum. So what are they asking? They are asking the ratio of their horizontal ranges, meaning they are asking you what is R1 by R2. You just need to do this. So you would get u square sine 2 times 30 is 60 degrees upon g, the whole upon u square sine 2 times 45 is going to be 90 degrees. Okay, upon g. What can you cancel? You can directly cancel the u square terms. You can also cancel the g term. So what are you left with? You're left with sine, is it sine 90 upon 60 or sine 60 upon 90?
60 upon 90. Sir.
Correct. Sine 60 degrees upon sine 90 degrees.
Root 3
What
is to 2.
Yes, sine 60 is root 3 upon 2. Very good. And sine 90 is
1.
nothing but 1. Right?
Sir, but there is no option, no, sir.
Root 3 by 2. So, yeah. So this has to be, this is, the value is 60 times, let me just check. Yeah, root 3 upon 2 and sine 90. This is 45 is correct. Okay, it says D, the last option. So this has to be 2 children. Maybe there is a printing error here. Okay, it has to be, 2. There shouldn't be a root over there. Okay.
I got this answer, sir.
You got root 3 upon 2?
Yes, yes.
Yeah, it should be root 3 upon 2. Okay, maybe there is a printing error because in the answer key it is written root 3 is to 2 தான். இங்க அவங்க print பண்ணும்போது முன்னாடி இப்படி போட்டிருக்காங்க. சரி, fine. Okay. So this is the method to do this question. So it is root 3 is to Okay, fine, simple. This is how you do. For that formula based and situation based, you apply it and you find out the ratios, extract the ratios. Okay, we'll go to another model, a different model. We will see.
Lot of effort. Yeah.
Okay, so here comes the next question. I hope question number 3. So I'm writing it here. Third question. Okay. A particle is projected with a velocity u, so that its horizontal range is twice the greatest height attained. The range is. So we have options here. A is u square upon g. B is 2u square upon 3g. C is 4u square upon pi g. D is none of these.
Sir, u square upon g.
U square upon g. No, it is not u square upon g. Twice the greatest height in சொல்லிருக்காங்க. They are told it's twice the greatest height. Greatest height na in the sense it is maximum height. So what is the maximum height of the projectile? U square sin square theta by 2g. Yeah. So you will have to think in that direction. This is a application based question. So inga vanda first you will have to give a relation. ஒரு relation கொடுத்திருக்காங்க questionல என்ன சொல்லிருக்காங்க? They have mentioned that it is projected with a velocity u, that is okay, so that its horizontal range is twice the greatest height attained அப்படின்னு சொல்லிருக்காங்க. So what does that mean? It means the range is equal to 2 times h max. Yes or no? Isn't this the relationship?
Yes.
Right? Yeah. So use this relationship. So range formula we already know it. What is the range formula? Which is
u square sin 2 theta by g.
Yes, u square sin 2 theta by g is equal to twice maximum height. So 2 into maximum height of the formula, which is
u square sin square theta by 2g.
Yes. So this is the relation that we have. So here you go for a simplification. What are the terms that are getting cancelled? Gg is getting cancelled. And here the 2 is getting cancelled, right? Isn't it? U square also is getting cancelled, in fact. So what are you left with? We can say sin 2 theta is equal to sin square theta. That is the relation we are getting. Right? So how can I simplify this further? You apply the maths identity.
2 sin theta into cos theta.
Yes, 2 sin theta into cos theta is equal to sin square theta. So can I further simplify this and say 2 cos theta is equal to sin theta? Is it correct? Can I write like
this?
Yeah.
Yes.
Now go for a rearrangement. Don't you think I am getting tan theta is equal
tan
to?
Theta is equal to 2.
Yes, tan theta is equal to 2. If tan theta is 2, now we got a relation. Now in the question, they are asking us, what is the range? What is the range attained? So Therefore, we need to express, in terms of, get the answer in terms of u. So that means we need to eliminate sine and cos. We need to express sine and cos, in terms of of their ratios. If tan theta is 2, come on, tell me what will be sine theta and cos theta? What is the value of sine theta and what is the value of cos theta? Apply the Pythagorean, the triangle rule and find out. Yeah. What are you getting? Opposite by adjacent வந்து உங்களுக்கு ஏற்கனவே 2 ன்னு சொல்லி கொடுத்திருக்காங்க. That means 2 upon 1. So, what is sine theta?
Opposite by hypotenuse.
இல்ல அது what is the value? I wanted in terms of value. And the triangle உங்களுக்கு, I hope everybody knows to draw the triangle and get the ratios, right? You know how to draw this triangle. Put theta, right? And you put A, B and C. Here they have given tan theta is 2, meaning tan is nothing but BC upon AB, right? Tan theta is here BC upon AB, isn't it? So
Yes.
Yeah. So what is that? 2. If it's just 2, don't you think it's going to be 2 upon 1? If this is 2 and this is 1, what would be AC? AC, what is the value of AC?
Root 5, sir.
Exactly, it's root 5. If you have this triangle ready, what is sine and cos values from this triangle? Sine value will be opposite upon hypotenuse, which is
2 by root 5.
Exactly, it's 2 by root 5. What about cos?
1 by root 5.
Yes, cos is 1 by root 5. Now once you have sine and cos, you can find out what is the horizontal range, don't you? So now what is the horizontal range? Tell me. Formula. Horizontal range is equal to?
U square sine 2 theta by g.
Yes, u square sine 2 theta by g. Now sine 2 theta you have to express in terms of
2 sine theta cos theta.
Exactly. So 2 times sine theta into cos theta divided by g. So now you go and substitute. So u square into 2 into sine theta. Sine theta we have the values here, which is 2 upon root 5. Cos theta is 1 upon root 5. The whole valued upon g.
10.
Okay.
G.
GA vechikalam because you can see options are in terms of G. So now you go for simplification. What are you getting if you simplify this? Root 5 into root 5 becomes 5. Ilya?
4u square divided by 5g.
Yeah, you get 5g. On the top you're getting 4.
4u square.
So the answer is option?
Option C.
Option C. Is it clear how to approach such questions?
Yes,
Okay.
sir.
Yes, this is the method. This seems to be complicated, but first what we did, we got the relation. Building the relation is very important. Whenever you see questions like this, first build the relation, try to substitute, then get, so here we got the trigonometric, application where tan theta was 2, but you can see horizontal range is in terms of sine 2 theta. So that's the reason we found out sine and cos in the first place. And then you go and substitute them, and then finally you simplify, you will get the answer. So this is the method to solve this question. I hope everybody is clear with this. If you want, I'll minimize so that you can see the entire thing in one screen. So this is the method to solve such questions. Fine. So shall we move to the next one? I hope this is
Yes.
clear. Yeah. Going to the next question. Question number 4. Okay. The speed of a projectile. The speed of a projectile at its maximum height is root 3 upon 2 times its initial speed. is root 3 upon 2 times its initial speed, full stop. If the range of the projectile is p times the maximum height, is p times the maximum height, then the value of p is, then what is the value of p is what they're asking. I'll give you the options. Option A, 4 upon 3. Option B, 2 root 3. Option C, 4 root 3. And option D, 3 upon 4. Again here, read the question carefully. Try to understand what is the relation and then try working towards it. I'll just give you a minute to think.
Option B, sir.
Option B. Okay, value. If you tell the value, it's easier for me. 2 root 3, right? According to you.
Yes, sir.
Okay. But unfortunately, that's not the answer. It's not 2 root 3. Yes, anybody else? No idea? First, you'll have to build the relation. I think starting, building the relation is where you guys are stuck. You get the relation correctly, the automatically all other steps would be, appropriately set for you. That is the crucial point. Who can tell me what is the relation from the first part of the question? It tells you that its maximum height is root 3 times its initial speed. What does that literally mean? What does this statement mean? Can you put it mathematically and tell me?
R is equal to P times of H. H max.
R is equal to, that is the second part. I'm asking the first part. That's correct. What you said is right.
Speed at
R
maximum
equals
height.
P times H. This is perfectly fine. But we can't use this now. We already have, an initial condition. Tell me how would you put that initial condition mathematically? Maximum height is root 3 times its initial speed. How do you write it?
V is equal to root 3 by 2 U.
Yes?
V is equal to root 3 times U.
Okay. So what component is that? Is it vertical or horizontal component? Which component of velocity is it? That's very important. Is it horizontal component of velocity or is it vertical component of velocity that they are talking about? Yes? It is horizontal. Okay. So VH is equal to, that H stands for horizontal component, is equal to U cos theta, right? Which is nothing but root 3 by 2 times U. Okay. This is what we try to understand first. Once we got this relation, what is cos theta from this? If U cos theta is
30 degree.
yes, you will get cancelled and you get cos theta is equal to root 3 by 2, which implies theta is cos inverse of root 3 by 2, that is 30 degrees. Okay, so you get theta as 30. Once you got this, now coming to the range part. Okay, now you know that range formula already we know, it is u square sine 2 theta upon g. Same way, what is maximum height relation, wherein h max is going to be equal to u square sine square theta upon 2g, isn't it? This is the relations that we know. Fine. So now we know, you already told me this relation wherein r is equal to p times h. That is what we are going to substitute. Since r is equal to p times h, that is h max. So I am substituting. So u square sine 2 theta upon g is equal to p times h max, relation, which is u square sine square theta upon 2g. Okay. Again, going for a simplification. So what happens? What needs to be cancelled? You cancel it. G can be cancelled. U squared also can be cancelled. I'm cancelling them. And finally, we are left with sine 2 theta can be written as I already taught you guys 2 sine theta times cos theta, which is p times sine square theta upon 2. You have 1 2 left there. Not forget that. So again, I think further you can simplify it. Okay. So what are you getting now? You get 2 cos theta is equal to p sine theta upon 2. Can we get again tan relation here? Right? So what is tan theta here? This implies, who can tell me the value of tan? Tan theta would be equal to
4 by p.
Yes, so it's 4 upon p. That is tan theta. So what is p? They are asking p value. Go for a rearrangement. P is equal to 4 upon tan theta. Already theta we have found out as 30. Substitute and get me the answer.
4 root 3.
Yes, as theta is equal to 30 degrees. So you finally get P is equal to 4 upon tan 30. And tan 30 value is how much? I hope it's 1 upon root 3.
1 by root 3.
Yeah. So it gets reciprocal and you get the answer as 4 root 3. So what is the value of P? P has got the value
4 root 3.
4 root 3. That's it. That's the answer. So the answer is option C. Okay. This is the answer. I hope this is clear. That's how you approach. Such questions, require us to relate trigonometry and then, simplify. So that's the reason I'm emphasizing on such questions. Okay, it's important. So I hope now it's clear how to do it. Yeah. So this is the approach to solve this question. Okay, so we'll move on to the next model. Okay, we'll see a different model now, a vector model. So I hope the next question number is 5. Okay, fifth question. Here we go. Yeah. A cannon. I hope you guys know what is a cannon. Okay, a cannonball is shot with a velocity p I cap plus q j cap meters per second. If its range is double the maximum height attained, then The correct relation is I'm giving you the options now. Option A, P is equal to 2Q. Option B, Q is equal to 4P. Option C, Q is equal to 2P. And option D, Q equals P. So this is a question. You have a cannonball shot with a velocity. So they have given you the component of, the velocity as a vector form, wherein your V bar is equal to P I cap plus Q j cap. The unit is meters per second. Okay, so this is given. And they've told you the relation, that is, the range is double the maximum height. They've given you a hint. So based on that, you will have to think and tell me what is the answer. Yes? Anybody got the relation? Or at least you can give me the starting point. Let's see how you're thinking.
R equal to 2 H max, sir.
R is equal to 2 H max. That's correct. Yeah.
From that, tan theta equal to 2, sir.
R is equal to 2 times H max. That's perfect. Okay. After that?
Sir, after substituting the formula, tan theta equal to 2, sir.
Okay. You're getting tan theta is 2. Okay. Correct. That's also right. Tan theta you will get 2. Okay. After that, how would you get the relation with Q and P then? Till here it's correct. How would you relate Q and P? They've given you the vector, no doubt. So how can you relate, tan theta in the vectorial form? That is where the answer lies. The relation lies. What is the components of the given vector?
X-axis and Y-axis.
Yeah, exactly. So can't you write tan theta as y-axis component upon x-axis component? Isn't it? Vy upon vx. Is it possible to write like this?
Yes, sir.
Yeah, so what is the y component corresponding to j cap or I cap?
J cap.
Exactly. So tan theta is also q upon
P.
Isn't it? See, now you can get the answer. So what is it?
So 2P is equal to Q.
So Q by P is equal to 2, which means Q is equal to 2P. Simple. Okay.
Nice.
So which is the answer?
Option C, sir.
Yes, option C is only right. Q is equal to 2P. Okay. So we have to also use the vector relation here. Okay. That's how you can approach this question. So both combination of vector and trigonometry. So that's how we do this. Okay, I hope it is clear.
Sir, can you tell me again the relation, sir? The tan theta.
Yes, tan theta is y-axis component upon x-axis component. That's actually a formula based on vector. See, you would have learned, no? For example, here they have given you v cap is equal to pi plus qj. This is what they gave, meters per second, right? So how can I find out v here? If v bar is this, what is v? Meaning modulus. Can't you write it as p square plus q square under root?
Yes, sir.
Isn't it? So what is the relation? What is tan relation? Tan theta relation for this? It will be Vy upon Vx, right?
Yes, sir.
Isn't it? That's it. That's how you get it. So when you want to draw the diagram and show it, again you can see that this will be your vector v, and vector v is going to make an angle of theta. So when you drop a perpendicular, so you know that this is going to be the x component. So x component is what? Vx component is going to be v cos theta. And what about the y-axis component? You drop a perpendicular there. If this is
Yes, sir.
theta, this is 90 minus theta, right? You know all that. So this will be v sine theta,
Tan
isn't
theta.
it? Hmm. So what will be tan theta? If you want tan relation, what is going to be tan theta now? From this,
Vy by
isn't it? Don't you think it is going? If this is nothing but vy, this is vy only. That is vertical component. Don't you think it will be vy upon vx?
sir. Understood.
Okay, that's it. That's how you get it. Okay, so we use this relation. Okay, so I hope it's clear for everybody. So moving on. So that's how you approach this. Okay, next going to a higher level question. So next question number 5. Two vectors alpha, okay, alpha bar and beta bar subtend an angle theta between them. If alpha plus beta, that is alpha bar plus beta bar, okay, and vector alpha minus beta subtend angles x degrees and y degrees with vector alpha, then tan x plus tan y is, then what is tan x plus tan y? That's what they're asking. Option A, alpha times beta sine theta divided by alpha square plus beta square cos square theta. Option B, 2 alpha beta sine theta upon alpha square minus beta square cos square theta. Option C, alpha square sine square theta upon alpha square plus beta square cos square theta. And option D, beta square sine square theta upon alpha square minus beta square cos square theta. These are the options. So they have given you two vectors, alpha and beta. They are subtending an angle of theta between them. Then they are asking you if alpha plus beta and alpha minus beta, they subtend angles x and y degrees with alpha. Then what is tan x plus tan y? That's the question. Yes, who can tell me what is the relation? Just think and try to get the relation. Just if you're able to start, I'll tell you how to end it. So it's quite interesting, in the direction in which you think. So you think, and appropriately you'll get it. Yes. Anybody wants to ask something or you want to say something, you can tell me. So what is the relation that you can use here? They have given you vectors. So again, the angle between them also is given. Yeah.
No idea, sir.
No idea. Okay, fine. No worries. See, here when they have given you the angle between vectors and they have given you, the relation between, the addition of vectors and the subtraction of vectors, they are subtending angles of x and y degrees. Okay. So you try to add two vectors or you try to subtract two vectors, no issues. Again, you are going to end up, getting the corresponding vectors, even if you're going for addition or, if you're going for subtraction. Obviously, they are going to be in, the same plane. So assuming that, you need to write down the relationship. So how can we, build a relationship here for this corresponding vector? So whenever you have two vectors, needless to say, so here they have given us two vectors, alpha and beta. Say this is vector alpha and say this is vector beta. And what is the angle between them? The angle between them is theta. That's what they mean. That's what they have given in the question, right? Now these two vectors are there. Now where will the resultant of these two vectors lie? Don't you think it is going to be a parallelogram? The resultant. So this is the resultant, isn't it? So how can you write the resultant? It is nothing but the sum, right? Alpha plus beta, isn't it? That's your result.
Plus beta.
Yeah. And that is also making a corresponding angle. Now the angle that it is going to make correspondingly with alpha. So they are telling that they are going to subtend angles x and y. Okay, appropriately. So x degrees and y degrees. That is what they mean. Okay.
Yes.
Yeah. Fine. So now, whenever in the parallelogram law, the resultant makes an angle. So direction of that resultant is what you should think. So if you think in that direction, you will get the relation. So what is the resultant of the direction of the resultant in a parallelogram law? Direction of resultant. not resultant relation, direction of resultant. Resultant you will directly tell R is equal to under root of alpha square plus beta square plus 2 alpha beta cos theta. Not this one. There is one more, which is called direction, which is tan theta. I mean tan, okay, in this case, this is theta is angle between them. So here, so say this is, x degrees. So tan x degrees. What is the formula that you will get?
Beta sin
Yeah,
theta
correct.
alpha plus
Divided by
alpha plus
divided by
beta cos
alpha plus beta cos theta. Correct. This is what is the relation that you will get. Okay. Once you have got this relation, now similarly by, see, for vector a plus b, this is I mean alpha plus beta, this is correct. What about alpha minus beta? So in that case, can't you write tan y degrees is equal to, same way we can write, that is beta sine theta divided by, this time it will not be plus, it is going to be minus, which is alpha minus beta cos theta. This is what we get. Okay. So what is this for? This is between vector alpha minus beta. Okay. That's why I'm taking a minus sign. So once you have got these two, you can easily get the relation for tan alpha, I mean tan x degrees plus tan y degrees. So that relation, you can find out.
சார்.
Okay. As per the question. Yes. சொல்லுங்க.
சார் tan y-ல வந்து பீட்டாக்கு முன்னாடி நெகட்டிவ் வராதா சார்? நியூமரேட்டர்ல முன்னாடி மைனஸ் வராதா சார்?
Numerator முன்னாடி minus sign. No, you don't get minus sign. Yeah. Why don't you get? That is minus beta. Yeah. I mean minus beta bar. No, because the angle is 180 minus theta. Yeah. That is the reason. The angle between vector A and the other one is negative vector abin sollumbodhu. So I do understand that you feel that there should be a minus, but the angle is 180 minus theta. So minus of minus will ultimately become plus. No. Okay. That's why you don't get a minus sign there. Fine. So it's beta sin theta upon alpha minus beta cos theta. In the மாதிரி தான் உங்களுக்கு relation வரும். So once you have got this, now can you tell me what is tan x plus tan y? Simplify பண்ணுங்க. Tan x degrees plus tan y degrees. என்னவா இருக்கும்? Just you need to substitute and simplify. Can anybody tell me the answer? Because you have the values in front of you.
1 minute, sir.
Yeah. So you need to substitute, the relation, children. You will have to simplify. Once you simplify it, you will get it. Okay. So just substitute beta sin theta upon alpha plus beta cos theta plus beta sin theta upon, yes, சொல்லுங்க.
Options.
Options, yeah, these are the options.
Option B.
Option B.
B.
Second one, yeah, second option.
Second. Yeah.
Yes, correct. It is option B, right? Okay. Yeah, if you simplify pandingana, you will get it. So you take, I think you take the LCM, you should be able to get it. So what is the LCM term? A plus, it is of the form A plus B into A minus B, which will fetch you A square minus B square. So alpha square minus beta square cos square theta varda. Yeah, I think this is what you will get. And what about the top terms?
So B sin theta will get alpha minus B cos theta plus B.
Yes.
Alpha plus B cos theta, then taken out B sin theta.
Okay.
So that
I think the minus beta square sine theta cos theta and plus beta square sine theta cos theta is getting cancelled off. Once two terms gets cancelled, you will be left with 2 times alpha beta sine theta, isn't it? You'll be left with this
yes,
term.
sir.
Okay. So that is your answer. So the answer is option B. Okay. So you simplify it correctly, you will get the answer. Okay. That's how you approach this type of questions. All right. So that's it. So these are the different models which are there. Okay. That you should be aware of for projectile motion. Quite important. Related questions. So next we'll move on to the next chapter related questions, laws of motion. So we are moving on. So we have seen questions, ample questions from these projectile motion. So moving on to the next topic itself. So laws of motions, I hope you guys are aware about the basics for laws of motions. You know it, or you want me to brush up the basics for laws of motion? The concepts for this topic. Yes. So everybody knows the concepts based on laws of motion. So you're aware about it. We can go to problems directly. Otherwise, I'll give you the concepts, the formulas, and the concepts for this, and then we'll move on. What do you say? Yeah.
Your wish, sir.
My wish. It is student's wish. So all of you are aware about laws of motions, the formulas.
Yes.
You're aware. Okay. Fine. Okay. In that case, we will move on to the questions. But there are certain basic the diagrams are there. Very important. Free body diagrams are there. So based on that, the concepts are quite important. So I'll just give brief of those concepts because that is necessary. So once I give that, you can directly, we can go to the questions. Okay, fine. So now we'll see the important formulas and the concepts. So first one is for Newton's laws, relationship. So I hope you guys know, according to Newton's second law, we have the relation force equals mass into acceleration. Okay, this is one quite necessary relation that you know. Same way, momentum relation.
Yeah, P is equal to mv.
Product of mass times velocity. That's also necessary for us. Same way, the relation for impulse. Impulse can be written as the product of
Force into time.
Force into time, which can also be written as MAT. You substitute for force, you get MAT, and then can also be expressed as change in momentum, which is delta P. Okay, so these are the relations for impulse, quite necessary. And then we have the impulse can also be expressed in terms of integral sign, that is integration function. So impulse can be expressed as I is also equal to integration of f into dt. Okay, so time t1 to t2 we can say, we can express as an integral also. This is also quite important. And after that, we also have the relation between I think kinetic energy and momentum relation you guys should be knowing. So kinetic energy, the formula is half mv squared, and momentum is m into v. So how can we write this in terms of momentum?
Of T into V.
Half p into v. Okay. So what will be momentum in terms of kinetic energy then? It can be written as under root 2 mke, right? So this is the relation between momentum and kinetic energy. Okay, where P is under root 2 mke, where m is mass, ke is your kinetic energy. Okay, so this is an important relation. And after that, we have an important theorem called theorem of Lamy or Lamy's theorem. You guys are aware about Lamy's theorem?
No, sir.
Okay, I'll tell you. Lamy's theorem gives you the relation, between three forces that are concurrent. Concurrent means they have the same point of action, like this. So say if I have three forces, say force F1, F2 and F3. Let me name them. This point as O, and I'll name this as A and this point as B. And let me have another force also at the bottom. So we'll call this as F1, force vector F1. This is F2 and this is F3. Okay. And the angles between them. Let's take the angles between them as alpha, beta, and gamma. So we have a relation between the forces. So that's given by the theorem of Lamy, which says F1 upon F1 upon alpha. Meaning, how do I say alpha? It is the angle opposite to it. Okay. So F1 upon sine alpha is equal to F2 upon sine. So here it's F2 upon sine beta or sine gamma. It is sine gamma.
Beta, sir.
Beta, sure. I have taken gamma, no? Opposite to F2. That is equal to F3 upon sine beta. Yes, somebody was telling something. Yes.
சார் இதை ஃபினிஷ் பண்ணிட்டு கொஞ்சம் நீங்க காட்டிங்கன்னா நான் நோட் பண்ணிக்கிறேன் சார்.
Sure. கண்டிப்பா. Okay. Yes. So this is Lamy's theorem. So Lamy's theorem la வந்து when three forces are acting between the angles alpha, beta and gamma, we can express them as their ratios of forces and the sine angles opposite to the force that is acting. So F1 opposite to F1 பாத்தீங்கன்னா இங்க alpha இருக்கு, அதனால தான் F1 upon sin alpha. Opposite to F2 பாத்தீங்கன்னா gamma இருக்கு, that's why I put sin gamma. Opposite to F3 you can see it's beta angle, so that's the reason it is sin beta. So this is a relation. This relation is very useful for solving many problems. Okay, so that's why we use Lamy's theorem. And then we have, okay, when a person is moving in the lift, for lift related questions also, frame of reference அப்படின்னு சொல்லுவோம் popular. So based on that also questions can come. So you have the weight of the man in the lift அப்படின்னு சொல்லுவோம். So we'll see that weight of a man in a lift. Okay, so we'll see that. So there are different cases here, children. That's quite important for us. So we see first case 1. When this lift is at rest, that is, so lift at rest I've been photographed. Okay, when lift is at rest or it's moving with constant velocity, then the weight is going to be equal to m into g. Okay, so this is basically the apparent weight. So the apparent weight and the true weight both would be same. So this is a relation for lift at rest. Okay, then case 2, second case, when lift is accelerating upwards. Okay, so lift accelerating upwards. When lift is moving upwards or accelerating upwards with acceleration A, then what is the weight? That is given by weight is equal to, it will be mass of the person and the acceleration of the lift, which is upwards. So m times g plus a. This is the formula that we use for lift accelerating upwards. Quite important. Case 3, third case, when lift is accelerating downwards. Lift accelerating downwards with acceleration A. Then what is the relation? Let's see. Then the relation is the weight is going to be m times this time g minus a, because it's going downwards or accelerating downwards. Simple. So this is the formula. This is case 3. Okay. Next, case 4. Additional case. If the cable of the lift breaks, you will consider the lift to be a freely falling object, isn't it? When cable breaks, what happens? It is considered as object in free fall. Then the lift acceleration and the acceleration due to gravity both would be same. So therefore, you can see that weight is equal to m times your a, that is, we have it as g minus a. You can use this relation, but both g and a are equal, so it will be 0. Okay, so it becomes 0 when it is in free fall. So these are the relations. Okay, because you have a condition here, that is a is equal to g. So these are the different cases for lift. Okay, and now we are moving on to the next concept. And a person climbing a rope. Okay, so if a person is climbing a rope, then what happens? Then, what is going to be the tension in the rope? Okay, say we have a rope tied to the roof like this, and person is climbing this rope. Okay, so there is a person who's trying to climb the rope. So if a person is trying to climb the rope, then what are the relations? Let us see. So person is having a mass of m, okay, where m is mass of the person, and T is nothing but the tension in the rope. Okay, these are the conditions. I mean, this is the situation that I've given. I've depicted also diagrammatically. Okay, so when person climbs the rope, so this is also got cases. So case 1, person climbs up the rope. So first climbing up. So when person is climbing us up, what is the relation with tension? So then the tension is going to be equal to the m times g plus a. Okay, acceleration due to gravity plus, because he's climbing up or accelerating upwards. This is case 1. Case 2, when person climbs down, when he is climbing downwards, again you will just change the sign. So T is equal to m times g minus a is the relation that you will get. Okay. If the person is going to climb up or climb down, next is the third case. Either climbing up or down with uniform speed. Either climbing up or down with uniform speed. In that case, tension is going to be equal to weight of the person, which is m into g. Okay, so these are the 3 different cases for a person climbing a rope. Okay, so these are certain cases that are necessary. It's important. All right. So yeah, next we are going to see the basics for motion of bodies that are connected. So we'll be looking at certain free body diagrams also for that. That's also very important. So we'll see the next part. So what is the number? 10. Okay, 10th one. So next we are going to see motion of say connected objects. And FBDs. FBD stands for the free body diagrams. Okay. First one, quite popular. So under this we have again different, cases. So we will see case 1. So motion of blocks in contact with each other. So first we'll see 2 blocks in contact. So this is a ground level, and where we have the blocks connected. So say we have 2 blocks M1. This is one block, smaller block, and let me draw another bigger block next to it whose mass is M2. Okay, and I am applying a force like this towards right. Say the force is F. Then what is the object? What is the object's combined acceleration? So we need to write the expression for that. So you have 2 blocks A and B. A has got a mass of M1, wherein block B has got a mass of M2. So what is the acceleration of this block? Very simple. You know that force is equal to mass into acceleration, right? You can itself derive the relation. So what will be acceleration? Rearrange. Force upon mass, isn't it? Here is it just one single mass? Don't you think it is a combined mass of both the objects?
M1
So
plus
it will
M2.
M1 plus M2. So this would be the acceleration of the system of 2 blocks pushed by using a force of F. Simple. Next we are moving to case 2. So where I am going to now again have 2 blocks, but I am connecting them with a string or a rope. Again there are 2 blocks, no doubt. So block M1, and I am going to have another block, say M2. This time I am connecting them using a string like this, and then I am applying a force towards the right. I am trying to pull the system of blocks between ropes. So there are 2 blocks A and B. Now you know that there is going to be a tension that is going to act between blocks M and 2, that is A and B, connected by a rope, and that tension is going to be T. Okay, then what would be the relation for acceleration? Acceleration relation is no doubt it is the same thing, because force equals mass times acceleration. So I can simply say A is equal to F upon M1 plus M2. There is no change in this. But what would be the tension? The relation for tension. So it would be, because you can see that there is a direct contact with the force on block M2. So we can write tension as M1 times F upon M1 plus M2. Whenever you have systems that are connected together, you can apply this formula, and you can get the relation for tension, because you can see the tension remains same because it's one single rope that is connected. Okay, simple. So this is this is the relations for case 2. Okay, next we have the third case, different case. Case 3. Say we have a big string, okay, and a block is connected to it. So motion, let me call this motion of a block. Motion of a block with a massive string. Motion of a block with a massive string. So I'm taking a block, say block N. I'm connecting this to a spring, big, huge spring. Okay, and then force has been applied on the spring. Okay, so obviously the block is going to move with some acceleration. So what would be the acceleration? The spring has also got some mass. Okay, let me differentiate. The mass of the spring, I will use capital M. So what would be the acceleration? In this case, again, you apply the Newton's laws, you will get A is equal to F upon M. Here it's combined mass of both block and the spring together. So this is the third case. Okay. So next, fourth case, we have a pulley system. Okay. Pulley connected. A pulley connected to a system of 2 blocks. So we have a pulley. Let's quickly draw a pulley. This is the ceiling or the roof, and I'm drawing a pulley here. So we put a pulley, and I'm connecting 2 blocks to this pulley. So this is mass M1, and we have, say, another mass M2 also. Okay. Now here I am applying a condition. I am saying M2 is greater than M1. Okay, you know that this system is going to be in motion because one of the blocks are greater than the other. Block M1 would eventually move upwards with acceleration A. Block M2 would move downwards with acceleration A. And there is going to be tension also acting on the rope. Okay, and remember, tension is the same because it is the same rope that is going upwards, the pulley. The ropes are not different. It is the same rope. That's the reason the tension is also going to be same. It's not changing. All right. So the blocks are also going to they're going to experience a downward force due to gravity. That is the weight. So M1 G would act downward the block M1. So similarly, M2G is the weight component acting downward of block M2. All right. So this is, the complete diagram, the free body diagram I've shown you here. With respect to the entire pulley. Okay, I've shown everything, all the forces here. So now we wish to write down what is the acceleration for this system. So the acceleration relation is M2 minus M1 upon M1 plus M2, the whole into G. This is the acceleration of the system. Tension of the system can also be written. So tension is 2M1 M2 upon M1 plus M2 into G. So this is the relation for tension. Whenever you have 2 blocks going over a pulley, this is a relation that is very useful for us. Okay. So this is for pulley. So we are done with pulley now. Again, we have different cases also for pulley. This is one of the cases. Okay, moving on to the next one. So this is case 5. So moving on to case 5. So say I am having a pulley attached as shown. Okay, so we have a vertical ramp like this. Okay, and you can see that there is a pulley attached here at this end. Okay, and there are blocks which are there. So there is a rope also which goes. One block is suspended like this, and the other block is kept on the surface as shown. So here there is another block. So say this block mass is M2 and this block mass is M1. And this is moving downwards with acceleration A. This is moving leftward, M2 block. And the tensions are T. It is the same rope again. So obviously the tensions acting would also be same. Okay. So this is what we have. Block M1 also would have an additional weight component acting vertically downwards, which is M1 into G. Okay. So this is the diagram. Now the surface is also quite horizontal and smooth. Okay, so we imagine the surface is a frictionless surface on which the block M2 is kept. So this is a smooth surface, smooth frictionless surface. So smooth frictionless surface is there. And again M2 also is going to have a vertical downward weight, which is M2 into 3. So once you have shown all this, so we can write down the expression for acceleration for this also. So acceleration of this system is given by m1 upon m1 plus m2 into g. This is the relation for acceleration. Same way, the relation for tension can also be expressed as m1 m2 upon m1 plus m2 into g. This is expression for tension. Okay, for case 5. Okay, and then we also have the motion of the object on the inclined plane. That's also quite important. So that is case 6. The next case. So that's nothing but motion of an object on a smooth inclined plane. So again we have an inclined plane like this, which looks like a ramp with an angle. So say this angle is theta, and then I am having a pulley also on the top. Here I am attaching a pulley to which a block is suspended downwards like this as shown, whose mass is m1. We have another block also kept on the inclined plane whose mass is say m2, and I am connecting them to the pulley as shown, and it is the same rope that is going. It is a slackless rope. It is going across the pulley and then connecting m1 also. So the tension here is also same. So it is T. Alright, so that's the tension. And then we show all the components here. Okay, because this is theta. Now the weight component of M2 that's going to act vertically downward, which is M2 into G. Okay, and if I'm going to draw a perpendicular downwards to M2, that component is M2G cos theta. Okay, and this angle also is going to be theta. It's same. Normal reaction would act vertically upwards. You guys know that, or the reaction force we call it. Okay, and you have M2G sin theta also acting towards the left of M2. So these are all the forces that come into play. Same way for M1, it is M1 into G downwards vertically because that's the weight component, and again acceleration directions I'm showing. So imagine that M2 is moving upwards with an acceleration A, M1 is moving downwards with an acceleration A as shown. So if this is the case, then we can write the expression for acceleration as M1 minus M2 sine theta. I've taken G as common upon M1 plus M2. Okay, upon M1 plus M2, the whole into G. So this is what we get, the expression for acceleration. Same way, the expression for tension can also be expressed as a product of masses of both the blocks times 1 plus sine theta into G upon the total mass of the system, which is M1 plus M2. So these are the
We will complete with this, Manish.
Yes, uncle.
Yeah.
Just one more,
Yeah,
diagram, and with that
okay,
we are
okay,
done.
okay, okay, okay.
Okay. So this is case 6. Now the last and final case with the blocks. So with that we'll wind up. So the last case for the day, case 7. So again, where we have an inclined plane, you can see that this time there are two angles of inclination, alpha and beta. One on the left and one on the right. Again, it's a smooth surface. You can see the pulleys are right on the top, as shown in the figure. So we have two blocks which are there on both the inclined surfaces, and let's call them M1 and M2. So we are connecting them to a wire like this. And I'm also showing the components. So the tension would act on the rope as shown. And the acceleration of both the blocks are towards the it's towards the pulley for M1, and it's downward for M2. Okay, because I am taking M2 is greater than M1. So that's the condition. So based on that, the expression for tension is the product of masses of both the systems upon sum of the total masses, which is M1 plus M2 times sine alpha plus sine beta. This time we are just adding them, that's it, into G. This is the tension. Finally, the acceleration component is M2 sine beta minus M1 sine alpha upon sum of the entire system, which is M1 plus M2, the whole into G. That's it. So these are the expressions for tension and acceleration of the system. Okay, so with this we come to the end of today's class. So go through all these concepts. So yeah, we have brushed up the concept of the entire chapter. So I will be posting this on the WhatsApp group also for your reference. You can go through it. So please come prepared with all this. So next class we can see all types of questions based on this chapter. All right.
Manish, this chapter is there for the last 45 years. நான் ஐஐடி எழுதும்போதுலேருந்து இருக்கு.
ஆமா ஆமா.
இது இதில் நிறைய கேள்வி வருமே இல்லை?
எஸ் எஸ்.
ஆமாம்மா. நான் எனக்கு நான் பியூசி மை 12th படிக்கும்போது அப்போ ஐஐடியில் இந்த கேள்வியெல்லாம் வந்துட்டு இருந்தது. எங்களுக்கு ஒன்று தலைகால் புரியாமல் நாங்கள் போய் எழுதணும். சொல்கிறேன் ஒரு பேச்சுக்கு. ஸோ ஐ திங்க் திஸ் இஸ் வெரி இம்பார்ட்டன்ட். ஐ சி லாட் ஆஃப் கொஸ்டின்ஸ் கம்மிங் ஃப்ரம் திஸ் ஏரியா. அட்லீஸ்ட் 3-4 questions I have seen in அப்பெல்லாம் ஐஐடி ஒரே எக்ஸாம் தான், 2 எக்ஸாம்லாம் கிடையாது. கரெக்ட். நாங்களாம் எழுதும்போது ஒரே எக்ஸாம் தான். அது அட்லீஸ்ட் ஏதோ ஒன்று நாங்கள் எல்லாம் ஆட்டு மந்த மாதிரி எல்லாம் போய் எழுதுங்கடான்னு சொன்னாங்க. எங்கள் சீனியர்ஸ் எல்லாம் போய் துரத்துனாங்கன்னு போய் எழுதணும். அந்த மாதிரி வச்சுக்கோங்களேன்.
சொல்லிட்டு இருந்தாங்க இல்லைங்களா? ஏஐட்ரிபிள் எக்ஸாம். ஏஐட்ரிபிள்
அது கொஞ்சம் அதுக்கப்புறம் நாங்கள்
அதுக்கு முன்னாடி
ஐஐடி எக்ஸாம் தான் பேர். அதுக்கு ஜெய் தான். அப்போ ஜெய் தான். தோஸ் டேஸ் கோயம்புத்தூர்லாம் ஒரு இன்ஸ்டியூட் கூட கிடையாது. கோச்சிங் எல்லாம் கிடையாது. அப்பெல்லாம் ஒண்ணுமே கிடையாது.
எல்லாருமே செல்ஃப் ஸ்டடீஸ் தான் பண்ணிட்டு.
அப்ப அன்னைக்கெல்லாம் we have only self study, maybe some books இருக்கும், அவ்வளவுதான்.
or group studies.
சீனியர்ஸ் கொஞ்சம் ஹெல்ப் us. மோஸ்ட்லி சீனியர்ஸ் கொஞ்சம் ஹெல்ப் பண்ணுவாங்க. அவங்களுக்கு தெரிஞ்ச சொல்லி கொடுப்பாங்க. அந்த மாதிரிலாம் இருக்கும். I remember all these things I studied. I think in PUC or somewhere. Of course, but we could not clear 80 because அவ்வளோலாம் நமக்கு நாலேஜ் அப்போ அவ்வளோ இருக்கல. பட் இதில் நிறைய கொஸ்டின்ஸ் வருது. அதுக்கப்புறம் நிறைய லாஸ்ட் ஒரு 10-12 years ஐ பீன் ஃபாலோயிங் இட் அப் ஜெய் இல்லையா? ஆல்மோஸ்ட் எவ்ரி இயர் யூ கெட் சச் கொஸ்டின்ஸ். எனிவே, தேங்க்யூ ஸோ மச்.